Greetings dear friends. In this video we will talk about classes and objects. So what are objects? Objects are the fundamental building blocks of an object-oriented programming system. If we look at the definition of an object, we can say that an object is an entity, real or abstract, that has some state and behavior. So whatever we see around us, like tree, table, chair, pencil box, pen, pencil, fan, whatever we see around us is an object. Even we ourselves are also an object. So let us take some examples of object, some more examples like dog, apple, bicycle, etc. All the objects, they have certain state and have some behavior. An object state are the attributes of an object, are the characteristics, and they describe the object. Object behavior is operations provided by or built into the object. Let us understand the object state and behavior with the help of some real life objects. So if we say dog is an object, then the state of this object is color, breed, hungry, etc. And the behavior of this object can be barking, fetching, wagging tail, etc. If we talk about apple as an object, its state can be shape, color, etc. And its behavior can be its taste, its juiciness, whether it is juicy or not, etc. So if we talk about bicycle as an object, the state can be wheels, gears, etc. And behavior can be accelerating, changing gears, etc. Now let us understand what are classes. A class is a way to bind the data describing an entity and its associated functions together. It is a set of objects that share common attributes and behavior. C++ allows to create software objects which are very much similar to real-life objects. Let us see how we can create software objects and classes in C++. Now the syntax for creating a class is, first we have to write the keyword class, which is followed by the user-defined name, the tag name for this class. Then we give the opening curly brace, and there are three sections in the class: private, protected and public. You can have any of the three sections or all of them depending upon your need. And we define data members and member functions inside these three access specifiers: private, protected and public. At the end of the class, we give the closing curly brace, which is followed by semicolon. Now let us create a class in C++, and we take an example as student class. So we first write down the keyword class, and it is followed by the word student, which is here a class specifier or a tag name. Then we give an opening parenthesis, opening curly brace. We are giving two sections or two access specifiers, private and public in this class. In the private section, we are defining roll number and name, which are the data members of this class. And in the public section, we are giving in data and out data, which are the member functions of the class. And see how we have given them. We are writing the return type and the name of the function. And then we are giving the statements or the definition of the functions, the work which we want to perform in this function. So in this function, we are inputting roll number and name. Similarly, in the second function out data, we are displaying roll number and name. So this is the closing curly brace, which is followed by semicolon, which indicates that this is the end of our class. Now let us talk about the various access specifiers which are possible in C++. An access specifier determines whether class members are accessible in various parts of our program or not. So there are three access specifiers: private, protected and public. Now in the private section of the class, the members are not accessible outside the class, and only member functions of the class can use the members which are written under the private section or the private access specifier. Also, these the members of the private access specifier can never be inherited. So if we talk about the protected access specifier, again they are not accessible outside the class and only the member functions of the class can use them, but they are different from private access specifier by the way that they can be inherited. Now if we talk about the public access specifier, they are accessible outside the class and all the members written under it can be inherited also. Now it is very important to note that if we do not specify any of these three access specifiers, private, protected and public, then by default all the members which are defined in the class are considered private. Also, in this video we will talk more about private and public access specifier, and we will talk about the protected access specifier in the inheritance video. Now class members. Class members can be categorized as follows. Class can have data members and member functions. Data members are the variables which describe the property of a particular class, and data members are generally kept in the private section, although we can keep them in the public section also depending upon our need, and keeping them in the private section keeps the data safe from accidental changes. Member functions are the functions which operate on these data members, and they are also called messages. A message determines what operation can be performed by an object. Objects can communicate with each other through messages. Only the member functions which are given in the class can be used to perform any operation on the data members of the class. We cannot perform any other operation except the operations performed by these functions on the data members of the class. Objects communicate with each other through messages. Now they can be defined in two ways, member functions. They can be defined either outside the class or inside the class. Now let us see how we can define member functions inside and outside the class. When we are defining a member function inside the class, they are considered inline by default. And for a function to be inline, the function code should be small and it should not contain complex looping and decision statements. It should be short and small. So let us take an example of class student again. We have written class followed by the name of the class. In the private section, we have given roll number and name as the data members. And in the public section, we are declaring member functions. We are giving indata as the member function, and this is the definition of this function. We are giving the statements to read the data members of this class. In the outdata member function, we are displaying the values of roll number and name. Now when we are declaring the function outside the class, we give the prototype of the function inside the class and the definition outside the class. Let us see how we can do it. In this, again, we are taking the example of class student. The private section, we are giving the data members, roll number and name. And the public section, you can see that we have only given the prototype of the function, and the real definition is given only when the class is ended here, you can see. Now, how can we define a function outside the class? For this, there is a syntax. We have to give the return type of the function first, which is followed by the name of the class to which the function belongs, and then the scope resolution operator, and then the function name followed by its argument list. So in this case, we can see that the function indata is returning void. It belongs to class student, and then we are giving scope resolution operator, and then we are giving the name of the function, and below it is the definition of this function in which we are inputting the values of the data members, roll number and name. Similarly, for outdata, we are first giving the return type, then the name of the class, scope resolution operator, name of the function, and it is followed by the definition of the function where we are displaying roll number and name. Now after defining a class, let us see how we can create objects. An object, as we have already discussed, is an instance of a class, and they represent variables of a user-defined data type class. The syntax for creating objects is we give the class name and followed by object name and semicolon. Let us take again an example of class student. So if student is a class, so we first give the class name, which is student here, and then we give the object name, which is 2 here. Object name is user defined. Again, we can give any name according to our choice. It is very important to note that the class specifications, they provide only a template and does not allocate any memory space. Very important to note. And the memory space is allocated only when the object of the class is created. So memory allocation is done when we are creating an object of this class. Now let us find out few more things about creating objects. When we create many objects of the same class, each object has its own copy of data members. And all the objects of the same class use the same set of member functions. Let us see it pictorially. Suppose there are 3 objects of class student S1, S2 and S3. So all the objects S1, S2 and S3, they have their own set of data members. You can see the roll number and name for object S1, roll number and name for object S2 and roll number and name for object S3. But you can see here that there is only one copy of the member functions in data and out data, and all the 3 objects, they are sharing only this single copy of member functions. This is possible because at a time only one object can invoke any function. 2 objects simultaneously cannot invoke one function. So we can keep only one copy of member functions. Also, the member functions are created and placed in memory only once when they are defined in the class specification. And this is feasible also because functions for each object are identical. All the objects, they have the same member functions. However, data items will hold different values for each object. Now let us see how we can access member functions through an object. Member functions can be accessed using a dot operator between the object name and the member function. The syntax for the same is object name dot and then the name of the member function. We again take the example of class student and an object stu. We can write down stu dot in data. The statement means that the function in data is being called for the object stu. And very important to note that only public members, whether data or functions, can be accessed by the objects of the class. Objects cannot access private and protected members of the class. This function call can also be described as sending a message in data to the object stu. And any reference to class data in the in data method will now be applied to the data members of the stu object. It means whatever data members we are referring to in this function in data, like roll number and name, they will be applied to the data members of the object stu. So whatever values we are inputting in this function, they will be stored in the data members of the object stu. Now nesting of member functions. When a member function of a class is called by another member function of the same class, it is called nesting of member functions. Now let us create a program, write a program to understand all these concepts. So we are writing a program to create a class travel plan in which the data members are plan code of type long, place of type character, number of travelers of type int, number of buses of type int, and there are member functions new plan, This function is used to assign the values of a number of buses as per the following criteria. If the number of travelers is less than 20, number of buses is equal to 1. If number of travelers is greater than equal to 20 but less than 40, number of buses is 2. And if the number of travelers is greater than equal to 40, number of buses is equal to 3. You can see that all these data members and new plan are to be the private members of the class as described in the question. And then there are two other member functions, get plan and show plan. Get plan function, in the get plan function, we have to input data for plan code, place and number of travelers. And then we have to call the function new plan to assign value to the data member number of buses. And in the show plan function, we are displaying the contents of all the data members. These two are public members of the class. Now let us implement it in C++. So you can see here, first of all, I will include all the header files, and these header files contain functions and which are being used here in this program. Next, I am declaring a class. The first is the keyword class, followed by the name of the class, which is travel plan here. In the beginning of the class, I am putting curly brace, and in the private section, I am putting plan code, all the data members, plan code, place, number of travelers, number of buses, and the member function new plan. And in the public section, I am defining functions get plan and show plan. This is the end of the class followed by semicolon. Now remember that all these private members of the class, whether data members or this member function, cannot be accessed by the object. Object can access only the public members of the class, which are get plan and show plan. They can be accessed only by the member functions of the class. Now, as we have declared all the functions outside the class, let us see how we can do it. Again, we are giving the return type of the function first, followed by the name of the class, scope resolution operator, and then the name of the function. We are giving the input statement seen for plan code, place, and number of travelers, and then we are calling the new plan function to assign value to the data member number of buses. So you can see the function call. This is how you can call one function inside the other function. Now we are defining new plan function, in which we are giving the return type first, then the name of the class followed by scope resolution operator. We are using the decision statement if here. If number of travelers is less than 20, number of buses is 1. Else if number of travelers is less than 40, number of buses is 2. Else number of buses is 3. And for the function show plan, I am displaying all the 4 data members, plan code, place, number of travelers and number of buses. Now the class definition is over. Now we will implement this class in main. So I am declaring main here, void main. I am clearing the screen using the clear screen function. Now next I am creating an object. So travel plan is the name of the class and TP is the name of the object. And I am using this object name dot and then the member function name to invoke this function get plan. So when I invoke this function get plan, it will come here, the program control. It will input plan code, place, number of travelers, and these are the values which are input. They will be stored in the object TP, and then it will call the function new plan to calculate the value of number of buses. And all these values will be stored in the data members of the object TP. Next, I am saying TP.showPlan. So when I say this, it will display the plan code, place, number of travelers and number of buses of the object TP. Now let us see the memory diagram of this program. So you can see here TP is an object of the class travel plan. These are the data members, plan code, place, number of travelers and number of buses. And these are the member function, new plan, get plan and show plan. Now you can see here this TP object can access only the public member function and it cannot access the new plan. New plan can be accessed only by these two public functions. So this is the memory diagram. Now, array of objects. Like we create array of any other type, any other data type, we can also create array of objects. An array of object is stored inside the memory in the same way as a multi-dimensional array. We can use the usual array accessing methods to access individual elements, and then we put the dot operator to access the member functions. So let us make a program to implement the concept of array of objects. Again, I am using these files, header files, same class travel plan, which has 4 data members, plan code, place, number of travelers, number of buses, and then there is a function new plan which is declared in the private section. There are 2 other functions, get plan and show plan, in the public section. Then the same definition of get plan, I am inputting the data members, plan code, place, number of travelers, and I am calling the function new plan. And this is the definition of new plan function, in which I am checking if the number of travelers is less than 20, number of buses is 1, if it is less than 40, it is 2, otherwise it is 3. Then we have the show plan function. Again the same code, we are trying to display all the 4 data members of the class. Now let us come to main. Now when I say travel plan TP5, here TP is not a single object, but it is an array of 5 objects from 0 to 4. Let us see the memory diagram of it. So you can see here, this is an array of 5 objects. The first element is the 0th element, TP0. The second is TP1. Third is TP2. Fourth is TP3. And the fifth one is TP4. And all these elements have 4 data members: plan code, place, number of travelers, and number of buses. And all of them they can access directly get plan and show plan. And new plan is a private member function which can be accessed by get plan and show plan and not by the objects directly. Now when I give the statement for int I is equal to 0, I less than 5, I plus plus, tpi.getPlan, so this loop will be executed for all elements of this array TP from 0 till 4. And similarly, there is one more loop to display the all the data members of all the 5 elements of the array from 0 to 4. Let us see this in detail in this slide. Let us see the working of this loop. So when I say for int I is equal to 0, I less than 5, I plus plus, initially the value of I is 0. So this statement will become tp0.getPlan, as you can see here. So the values input in the data members, plan code, place, number of travelers, and the value of the data member, number of buses, which we are calculating through new plan method, they are stored in the 0th element of the array TP. You can see here, this is the 0th element of the array TP, and all the values they are stored respectively at their own places. Similarly, like when the I is incremented, the value of I will become 1. So this statement will become tp1.getPlan. So whatever values of data members we input or calculate, they will be stored in the first element of the array TP. You can see here, this is the first element of the array TP. All the members or all the values of data members, they will be stored here in this an element. Again, the I will be incremented, and this time it will become 2. So all the values which we are calculating or inputting for the data members, they will be stored in the second element of the array TP. So this you can see, this is the second element of the array TP. Now similarly, for I is equal to 3 and I is equal to 4, whatever values we are inputting for the data members, they will be stored in the third and fourth element of the array TP respectively. And then again there is one more loop for int I is equal to 0, I less than 5, I plus plus, tpi.showPlan. This will also take place in the similar fashion as we have done here. So instead of inputting the value, this time it will display the values of the data members of all the 5 elements of this array TP. Objects as function arguments. We can pass objects to the functions as an argument, and it can be done in 2 ways, call by value and call by reference. So as we have done it earlier also, let us again revise it. In call by value, separate memory is allocated to formal parameters, and in call by reference, formal parameters share the same memory space as actual parameters. So let us see again what are formal and actual parameters. The objects in the function call are called actual parameters, and the objects which are present in the function declaration or prototype, they are called formal parameters. I hope now you remember this. Now in call by value, values of actual parameters are passed and they are copied into the formal parameters. While in call by reference, reference of actual parameters is passed to formal parameters. Now in call by value, any change in the values of formal parameters is not reflected back to the actual parameters. While in call by reference, any change in the values of formal parameters is reflected back to the actual parameters. And again, a very important thing, to pass the object by reference, the object name is always preceded by ampersand symbol in the function definition. Now let us write a program in which we are passing objects as function arguments. Again, these are the header files which are used in this program. I'm declaring a class time. Here this is a keyword and time is the name of the class. It has two data members, hour and minute. And in the public section, we have three member functions, get time, add time, which is adding two objects T1 and T2, and show time. Now we see the definitions of this function. In the definition of this function, we can see here in the function get time, it is accepting two parameters h and m, and we are assigning the value of h to r and the value of m to minute. In the show time, we are displaying hour and minute. And in the add time function, we are trying to add two objects T1 and T2, which are passed as parameters from main. So what we are doing actually, we are saying r is equal to t1.r plus t2.r, minute is equal to t1.minute plus t2.minute, and now we are checking if r is greater than equal to, it should be minute greater than equal to 60, then h1 is equal to r minus 60 and minute is equal to minute plus h1 and r is equal to r plus 1. Now let us understand this function through the function call. If we go to main, we are declaring three objects x1, x2 and x3 of type time, of class time. x1.getTime 2, 45 will assign value 2 and 45 to hour and minute of the object x1. Now the second statement will assign value 5 and 20 to hour and minute of the object x2. And now see, look at the statement. x3.addTime x1, x2. In this, we are passing x1 and x2 as object and this is passed by value. So the values of x1 and x2 will be copied to T1 and T2. So when I say T1.r, it is actually the copy of the values which are copied from x1, and T2.r is the time, value of the time which is copied from x2. And when I say hour and minute, this hour and minute will refer to the object x3, which is the object which is invoking this function add time. So when I am not writing any object name in front of any data member, they always refer to the object which is calling this function. So very important to note. Again I am repeating, if I am not writing any object name in front of the data members, so these data members, they always refer to an object which is invoking this function. So x3 in this case, so hour and minute, whatever values I am writing here, they will be the data members of the object x3. So when I say x1.showTime, x2.showTime and x3.showTime, the output will be hours 2 minutes 45, hours 5 minutes 20 of x2 and hours 8 and minutes 5 for the object x3. Now let us see the memory depiction of function arguments. You can see in call by value, we have the objects x1 and x2 have these memory allocations, and the object t1 and t2, which are defined in the function add time, which are the formal parameters of the function add time, they are given separate memory allocations. So if we are doing any changes here, these will not be reflected in the objects x1 and x2 of main. But in class by reference, we are passing the reference. So x1 and t1 they will share the same memory space, and x2 and t2 will share the same memory space. So whatever changes we are making in t1 and t2, they will be reflected here, and the actual parameters x1 and x2 also get changed in call by reference. Now let us talk about returning objects. We can easily return objects from functions just like we return any other variable. When an object is returned by a function, what happens? A temporary object is automatically created, and this temporary object holds the return value. And it is this object that is actually returned by the function, and after the value is returned, this object is also destroyed. Let us write a function to see how we can return an object. Again, we are taking an example of class time, which has two data members, hour and minute, and three member functions, get time, add time, and show time. Now you can see here, instead of void, I have written time here because we are returning the object time from this function add time. So in get time, we are simply inputting the value of hour and minute. In show time, we are displaying the value of hour and minute. And let us see how we are actually doing it in show add time. See, the first time refers to the return type of add time function. The second time refers to the name of the class followed by scope resolution operator. And here type t1 is the argument of the type of the function add time. Now in the add time function, we are creating a temporary object t3 of type time, and we are saying t3.r is equal to t1.r plus r, and t3.r is equal to t1.minute plus minute. It is very important to see how it actually works. If we look at the main, in the main we are creating three objects x1, x2 and x3 of time. We are getting the time x1 and x2, inputting the values for the two objects. And now look at the function call now. The function call is x3 equal to x2 dot add time x1. See here x3, this is an assignment statement because add time function is returning an object. So we need an object to receive that value. Now one object is passed as parameter here, and the other object is used to call this function add time, because functions cannot be called without the object name. So the values of x1, they are passed by value to the formal parameter t1. They will be copied. The value of x1, the data members of x1, they will be copied to data members of t1. And here if we see t3.r refers to the object t3, t1.r refers to the object t1, in which we have copied the values of the object x1, and r here will refer to the object x2 because the object x2 is calling this function add time. Similarly, minute here refers to the object x2 because x2 is an object which is calling the function add time. And now we are displaying, we are saying x1 dot show time, which means you can see here hour and minute. Now these hour and minute, they refer to x1. When we say x2 dot show time, again the same function is invoked, but this time hour and minute, they will refer to x2. And when we say x3 dot show time, hour and minute will refer to the object x3. Assigning objects. C++ allows assigning one object to another provided they belong to the same class. It is very important because even if the two classes have the completely same structure, we cannot assign one object to another unless or until they belong to the same class. And by default, when an object is assigned to another, a bitwise copy of all data members is made. So let us look at this concept using an example. Suppose we have class A, which has one data member A1, and it has two member functions get data and put data. Then we have class B, and which has one data member B1 and the member functions in data and out data. Here I am assuming that we have written the get data and put data functions, definitions of these functions. And then we are declaring main, In the main, we are creating two objects A11 and A12 of the class A, and we are creating two objects B11 and B12 of the class B. So again, I am using A11 to get data to input the data members of the object A11. So when I say A12 is equal to A11, this statement is entirely correct, and in this, the data members of A11 will be copied to the data members of A12. But if I say B11 is equal to A11, this operation is not allowed, even though you can see the entire structure of the class A and class B are same. But this statement is not allowed because B11 and A11, they belong to two different classes. So if you want to assign one object to another, this is possible only when they belong to the same class. So this is all for this session. I hope you like this video, and if you like it, please give the thumbs up, and you can also subscribe to my channel. Thank you.